Hi folks, welcome back to 10.3 not ellipses, hyperbolas. All right, so I'm thinking ellipses because this practice is actually a mixed practice. We want to help develop that idea of making decisions, okay? So if we take a look at this equation in number 2, this looks like x minus h squared over a squared plus y minus k squared over b squared equals 1. And so automatically, because of the plus sign, I'm thinking this is not a hyperbola, because a hyperbola would have the minus sign in between, but it is an ellipse. All right, so let's get started. I'm going to go ahead and find my center, which is going to be 1, 2. So 1, 2. And I know that if I want to go ahead and move out to find the vertices, I'm going to pick the bigger number, and I'm going to square root that. And so since this 16 is underneath the y squared, I'm going to go up and down 4 units. So 1, 2, 3, 4, and 1, 2, 3, 4. That makes my vertices 1, 2 plus or minus 4, which gives me 1, negative 2, and 1, 6. All right. Now let's find our covertices. So our covertices will be the square root of the number, and since it's underneath the x, I'm going to go 3 in each direction. And if I write that algebraically, I'll get 1 plus or minus 3, 2. That's going to give me negative 2, 2, and 4, 2. Now I can connect these to make my ellipse, but I also need to find my foci. So in order to find my foci, I'm going to use c squared equals a squared minus b squared because a is bigger than c for an ellipse. Now this is going to give me c squared equals 16 minus 9, or c squared equals 7, or c equals the square root of 7. All right, now how does that help us out? It allows us to find our foci. So again, we're going to take our 1, we're going to keep that, and then we're going to do 2 plus or minus root 7, because we're going from the center, we're going a specific distance. Now, if I move this, or turn this into a decimal, I'll get 1, negative 0.646. And with this one, I will get 1, 4.646. And so I can mark those points off on my graph. And now I have a complete graph of the ellipse. Now there's a box that says equations of asymptotes, but I want us to know better. It's not applicable here because this is an ellipse, not a hyperbola. Okay, let me just zoom out so you can see the whole question here. And then we're going to take a look at question number 3. All right, question number 3. So I look at this structure and I'm thinking that it could be an ellipse, but then I notice that there is a 16 and a 16. So the numbers on the bottom are the same. That means it's not an ellipse, but it is actually a circle. And so with a circle, I can say that this circle has a radius of 4 because that's the square root of 16. And I can find my center, 1, 2, same as before. I don't need vertices or covertices because it's a circle, and I don't need foci because it's a circle. So I'm going to graph the point 1, 2, and then I'm going to go out 4 units in every direction. And then I can connect everything to make to make my circle. All right? And again, it says equations of asymptotes, but we know better. There are no asymptotes for the circle, and so we really want to make sure we know how to recognize the different shapes. All right, let's move on to question number 4. So question number 4, well, let's take a look at this. I see a y minus k squared over a squared minus x minus h squared over b squared equals 1. All right, now the minus sign is the clue here. So I know that this is a hyperbola because of the minus sign. Now I'm going to find my center, which is going to be 1, 2. And we want to double check this, right? So I look and I see a 1 and I see a 2, and I'm like, well, I need to change the sign, so 1, 2. However, the x-coordinate always comes first, so we don't want to write 1, 2, we want to write 2, 1, okay? And that's a really easy mistake to make, so I just wanted to highlight that mistake. Sometimes when we're going too fast, we're like, oh yeah, this is what it is, and we don't double check our work, okay? All right, so from here, let's draw the box that will help us create our asymptotes. So what number's under the y? Well, it's 9, and the square root of 9 is 3, so I'm going to go up 3 and down 3 to create my points. Then, from the center, I'm going to go out the square root of 16, which is 4, and 4. And this gives me the box for which I can draw my asymptotes. So I know my asymptotes are going to go something like this, and like this. Okay? Now the question is, which direction do the branches open up at? And the way we tell is whichever one comes first. So since it's the y first, the branches are going to open down and up. Okay, now that's helpful because it tells us that these 2 points are our vertices. So those 2 are going to be 2, 1 plus or minus 4, or 2, negative 3. Oh, sorry. Not plus or minus 4, plus or minus 3, because I'm going in the vertical direction. So 2, negative 2, and 2, 4. All right. Let's get to our co-vertices. Those are going to be the other ones that were useful in helping us draw the box, but aren't necessarily where the vertex of the branches are. So we're going to do 2, 1 plus or minus 4, and that's going to give us 2, negative 3, and 2. My goodness, so many mistakes right now, Judy. Sorry, 2 plus or minus 4, 1. We have to go sideways from the x value of the center. So we'll get negative 2, 1, and 6, 1. All right, now we have to find our foci, and to do that, we're going to use the regular Pythagorean theorem, because in a hyperbola, c is bigger than a. So this is going to give c squared equals 9 plus 16, or c squared equals 25, and c equals 5. Okay, so that means that we're going to keep the x value of our center, and we're going to take the y value, and we're going to add and subtract 5. That will give me 2, negative 4, and 2, 6. So 2 comma negative 4 means that focus is down there, and 2 comma 6 means that other focus is up there. Now I have a complete graph. But because this is a hyperbola, I do actually need the equations of the asymptote. So for the up and down asymptotes, or hyperbolas, we're going to need to have y equals, and this is going to be the rise over run, okay? Now I know the book says b over a or a over b, but I think it's easier to think about it as the slope, or rise over run, and then x minus the h value plus the k value of the vertex. That means we're going to have plus and minus. The rise was 3 and the run was 4. And we have x minus 2 plus 1. And again, on an exam, you are welcome to leave it like that. And if you wanted to distribute, you can check your answers. They should be 3/4 x minus 1/2 and negative 3/4 x plus 5/2. All right, so let's stop here for this second video and come on back because we're going to do a whole bunch more examples. All right, see you there.